All right. Good morning, everybody. This is Mr. Ainsworth. We're going to get right into it. Our second part of Lesson 4. And we're going to talk about how to integrate trig functions that require two different types of U substitution techniques. And there are two basic types, so let's go over the two types here. In fact, let's just write it down over here on the right. There are two types of the U substitution that we're going to be looking at today. Two types of U substitution. Okay, first type and second type. All right, the first type that we're going to be looking at or using here is where we let U equal the angle only. So U equals just the angle within the trig function. All right, and the second type, when that doesn't work, is when we let U equal the entire trig function. Okay, so U is equal to the entire trig function. Depending on what you're given, you'd use one versus the other. So we're going to take a look at the first type, obviously, where we let U equal just the angle, and then go ahead and do our typical stuff with U substitution, and then also kick in what we know about the integrals of the trig function. So here we go. In this case, this is your angle, your 2x. There's your angle. So you're going to let U equal your angle there, 2x, because you can't just integrate cosine of 2x dx, because the only thing you know is the cosine, the integral of the cosine x dx. So whenever the angle changes something other than x, it usually involves a U substitution. Okay. All right, and at this point we want to find du. So we take du. Again, I'm not going to write it as du dx anymore. We're going to separate variables in our mind, and I'm just going to automatically put dx on the right-hand side. And the derivative of 2x obviously is what? 2. So I get du is equal to 2 dx. I'm going to separate variables automatically, so we're going to skip that step. Give me a thumbs up if you're with me on that. If you feel more comfortable writing du dx equals 2 and then split variables or separate variables, you go ahead and continue doing that. But from now on, I'm just going to separate variables all in one step, and you're going to see that later on too with all the other instructors here too. Okay, now notice there's no 2 right here. There's no 2 in the integral. It's not 2 times cosine of 2x, so there's no 2 there. So what I have to do is I have to isolate the dx. Right there, I have to isolate it. And then I simply divide by 2 or take a half on both sides. So I get 1/2 du is equal to dx, right there. And I want to substitute that in. That's going to go right in there for the dx. I'm going to have the 1/2 du. So now is the time where you want to rewrite the integral. Okay, remember U is 2x here. It's the angle. So it's going to be the integral of cosine of U, all right, times dx. But dx is 1/2 du, so times 1/2 du. Okay. Now at this point here, guys, remember all the constants. What do we do with them? Yeah, so if you want to skip this step and you automatically take out the constant like I do, okay, you can just go right to 1/2 times the integral, and that's going to be 1/2 times the integral of cosine of U, all right, du. So now you rewrote your integral in terms of U. You know what the integral of cosine is? It's what?
Sine.
It's no. Be careful. Is it sine or negative sine?
Sine.
It's sine, because what's the derivative of sine? Cosine. Okay, so it's just sine. So we're going to integrate now. It's going to be 1/2 sine of U plus what? C. What's C stand for? Constant of integration. Okay, and now what you do is you rewrite the integral in terms of x again, because you always end up with the same variable that you start with. So we're starting with x's. We're going to end with x's. So we got 1/2 times the sine of not U, but, well, right, U is equal to 2x. So we're going to have 2x there plus some kind of constant. All right, and this is the technique we're going to use for a while until that doesn't work, and then we're going to have to try something else. We're going to have to let U equal to the entire trig function. So the first thing you think of is this right here. You let U equal the angle, see what happens. If it works, great. Continue. If it doesn't work, try the whole entire trig function like we're going to try later. Okay, I'm going to pause the video. I want you to try number 2. All right, bring your eyes back up here. Here we go. I'm going to let U equal the angle again. So U is going to be equal to 7x plus 5. All right, du is going to be 7 dx. Check all your steps as we go. And I don't see a 7 here in the lead coefficient of the sign, so I'm going to divide by 7 or multiply by 1/7. And I get 1/7 of u is equal to dx. And this whole thing is going to be substituted in for dx right there. So 1/7 of u. And so I'm going to rewrite the integral in terms of u. Who's already bringing the 1/7 out as the lead coefficient there of your integral? Okay. So you can start off with the 1/7 here to save yourself some time, because you know you're going to do that anyways. And you're going to have 1/7 the sine of u, du this time. You guys speak up if you have questions as you go. Okay, now the integral of u is a function whose derivative, excuse me, the integral of sine is a function whose derivative is sine. What would that be? Negative cosine. Not just cosine, because the derivative of cosine is negative sine. So you have to say negative cosine. So it's going to be equal to negative 1/7, oops, 7, times the cosine of u plus c. Okay, bring back u in, bring back the 7x plus 5, and you get negative 1/7 times the cosine of 7x plus 5 plus some constant. Who got it right on their own there? Okay. Any questions up to this point? Okay. I'm going to pause the video again. I want you to try it again. Okay? Let's check work. Okay, I'm going to let u equal the 4x. Again, the angle. Okay, so u is going to be equal to 4x. I got du is equal to 4 dx. And there's, look right here, there's no lead coefficient that has a 4 there. So I've got to multiply both sides by 4 and get 1/4 du is equal to dx. And that right there is going to be substituted in. Okay, in for the dx. So when after I rewrite your integral, it's going to be 1/4 times the integral of cosecant u. I can barely see my computer here. Times cotangent u du. Got that far? Okay. So now that we need to find a function whose derivative is cosecant u. Cotangent u, and what is it? Yeah, in fact, that wasn't discussed in the homework problem just a few minutes ago. So this is negative 1/4. Who got the negative right? Okay. Cosecant u plus c. Okay. And then, of course, you got to substitute the 4x back in. So negative 1/4 cosecant of 4x plus c. Okay. Give me a show of understanding so far. This is full thumbs up. To the side is pretty good, and this is very, to the side is not very good. Where are you at? All right. Okay. I'm going to pause the video one more time. Work here, because I know you guys are working ahead. So I'm going to let u equal to x cubed. Okay, again, the angle, not x squared, but x cubed. Du is going to be equal to 3x squared dx. And in the integral, I see dx and x squared, not 3x squared. So I'm going to multiply both sides by 1/3. Okay, so I get 1/3 du is equal to x squared dx. So this right here is 1/3 du. You got to make that substitution in and then rewrite the integral in terms of u. So the integral of, well, I'm going to bring out the 1/3 of sine of u du. Okay. And the integral of sine is what?
Negative cosine.
Negative cosine. So this is equal to negative 1/3 cosine of u, but u is x cubed, so skip a step, plus c. Who got it right? Who's already skipping that step? Instead of writing in terms of u, you're just bringing back the x's in all the time. Okay. As you get more and more experience, you're going to be skipping more and more steps. So just be careful and check your work as you go. Okay. Who's already done number 5?
You can't do number 5.
All right, let's check work here. Your u is going to be equal to x divided by 5. So du is going to be 1/5 dx. And I'm going to distribute this 2 out of the integral here. And it's definitely not 5, so I'm going to multiply both sides by 5 and get 5 du is equal to dx. This is going to be substituted in right there. So who sees that the 2 and the 5 are going to be multiplied together on the outside of the integral? Okay, so so taking out the 2 first, I get secant squared u times 5 du. Okay, times, and then that 5 is going to be brought out, and you're going to multiply the 2 times the 5. So you might as well just integrate 10 times the integral of secant squared u du. So the integral of secant squared is a function whose derivative is secant squared, and what would that be? Tangent of u in this case. So it's 10 times the tangent of u, but u is x divided by 5, and then plus c. Okay, let's turn the page. Okay. Okay, now we're going to need another type of u substitution, and you know, this was already discussed in the homework problem here. So I'm going to pause the video and let you do this, and let's see how fast you can do it on your own, because you just saw it, okay? Just about 5 minutes ago. So go ahead and get started on number 6, and then I'll discuss it in a minute. You should be done. Here we go. Whoa. U equals cosine x du is equal to negative sine x dx. So negative du is equal to sine x dx. So all of this right here in the numerator, that's negative du. Okay, it's the same thing right there. So I'm just going to rewrite the integral now. So the integral of negative du divided by u squared. Okay, just straight substitution right there. And that's the same thing as negative the integral of u to the negative 2 du. And you can just kick in your power rule. You add 1 to the exponent, divide by that value. Why is it? No, the derivative of cosine is negative sine.
Oh, wrong way. All right.
Yeah, no, that's the tough about when we start integration. Very often, which just happened to you, is that you get your differentiation and integration rules mixed up. That happens all the time in the beginning. But after a month or two, you'll get it down. And then you get negative u to the negative 1 divided by negative 1 plus c. And that simply is 1 over u plus c, which is equal to 1 over sine, no, whoops, that's not it. U is equal to cosine. Didn't I? Yeah, okay. Doing this right. 1 over cosine x plus c. What's 1 over cosine x? Okay, who got it right on this one? Secant x plus c. Any questions on that one? Yes.
You just use x. Just use x.
It won't help you. No, you have to let u equal to the entire function.
All right.
Okay? Okay, now to a tough one.
Tough.
Okay? This is a lot more challenging, so let's talk about this for a second. All eyes up here. Does anybody? Eyes up here now. This is the hardest one on the whole lesson so far. Does anybody know a function whose derivative is sine squared x?
Maybe. Yeah, 1 minus cosine squared. Yeah. 1 minus cosine squared.
No, I said whose derivative.
Oh, yeah.
Okay, so who's having difficulty right now? You should raise your hand. Okay, because this is not so straightforward. We don't know a simple function whose derivative is sine squared x. So what you're going to have to do is you're going to have to use some identities from the past, and you're going to have to manipulate them and try to get a function that you can integrate, because right now you can't integrate at this point. Okay, so let me recall something from the past. Here we go. Yeah, recall, read, you know. A double angle formula. Cosine of 2x. There were 3 versions of that. Okay, now I want the version, look up here, I want the version involving sine squared x. Who remembers it? Brian? No, it's the other way. 1 minus 2 sine squared x. 1 minus, everybody say 1 minus 2 sine squared x. Okay, let's write that down. Okay, so this identity right here, if we isolate the sine squared x, will give us a function in terms of cosine, which is not being raised to a power. Okay, so we're going to isolate the sine function, this one right here, We're just going to isolate that. We're going to make a simple substitution, then integrate. Okay, so here we go. We're going to subtract 1. So we get cosine of 2x minus 1 equals negative 2 times sine squared x. I'm going to divide both sides by negative 2. Okay, and because the denominator has a negative in it, you don't leave it like that. It's kind of messy. We're going to bring the negative upstairs and distribute it through the binomial. And who sees that that's going to just change the sign of the terms up top? Okay, so instead of cosine of 2x minus 1, what is it going to become? Okay, negative cosine of 2x plus 1, but switch the order. What do you get? All right, so 1 minus cosine of 2x, all divided by 2 is equal to sine squared x. Okay. Okay, so now we're going to substitute that in. So instead of integrating sine squared x dx, we're going to integrate what it's equivalent to instead. So let's substitute in and then integrate 1 minus cosine of 2x divided by 2 dx. So all I did right there is just straight substitution. Okay. Now that's a fraction. So what we want to do is split the fraction. So it's going to be 1/2 minus cosine of 2x all divided by 2. Okay. We're going to write two different integrals. So here we go. Integral of 1/2 dx minus the integral of cosine of 2x divided by 2 dx. I just split the fraction, integrated both parts. Okay? Now the first one's easy. The integral of 1/2 dx is the same. We need to be thinking of a function whose derivative is 1/2. Right. So you just get 1/2 x there. Now it produces a constant, right? But the other integral produces a constant as well, and when we combine constants, we just get a single constant. So I'm just going to write a single constant when we're all done. Now look at the other function here. Look right here. It's not x, it's 2x. So that requires a u substitution. We're going to let u equal to 2x right there. Okay, it's not just cosine of x, so it requires a u substitution. I'm going to let u equal to 2x, just the angle, so it's like the first part of our lesson today. Okay, it's the first technique. We get du is equal to 2 dx. All right, and then, because there's only dx right here, I'm going to have to multiply it by 1/2 on both sides, and I get 1/2 du equals dx. So this portion right here is just going to be 1/2 du. Give me a thumbs up if you're with me on that. Okay, now there's going to be, so let's rewrite the integral. Here we go. So go to minus cosine of u now, okay, divided by 2 times 1/2 du. I'm not skipping any steps because I want you to see something here. Who sees 1/2 times 1/2 in the integral there? What's 1/2 times 1/2? So bring the 1/4 out of the integral. So you get 1/2 x here minus 1/4 of the integral of cosine u du. Now that you can integrate. The integral of cosine is a function whose derivative is cosine. What is it? Sine, because the derivative of sine is cosine. So you have 1/2 x here minus 1/4 sine u. Well, let's skip a step. What's u? 2x. So let's bring 2x back in automatically. Plus c. Okay, so here's our end result. Okay, now here's the deal though. Eyes up here. This integral, the original integral there, the integral of sine squared x, comes up from time to time. And you have two choices. You can recall the trig identity from last semester in pre-calc and work through this and generate that, or memorize it and go through all this integration here and then do your u substitution and do all this. Might take 3 to 5 minutes, you know. Or you can memorize the results. Okay? Now because it takes so much and that comes up from time to time and we're going to use it later on, I suggest that you memorize it. Put down the word memorize here. I'd memorize it because It does come up, and if you want to be quick and you want to use this on other results, which you need, you should have it memorized. Okay. Now, it's written a little bit different way. You're going to see it like this: x divided by 2 minus sine of 2x, all divided by 4 plus c. You're going to see that in your textbook like that. So let's highlight that one too. Let's memorize this. Commit it to memory. Okay. Okay. Now, if you understood that one, then you can try the next one. Okay. Okay, so here's the deal. This integral number 8 is just like number 7, right? It's in the same form. It's integral of sine squared of something dx. Okay, so what you're going to have to do, since this is not just x right here, it's 5x, you're going to have to do a u substitution right off the bat. You're going to let u equal to 5x and then rewrite it in terms of u, and then hopefully the light bulb will kick on and we're going to use our prior result and not do that whole thing over again. Okay? So there's your u. So we're going to let u equal to 5x here. And we're going to get du is equal to 5 dx. Okay, now I only see dx right there, so I'm going to take 1/5 of both sides. So 1/5 of du equals dx. And this portion right here gets substituted in for dx. So when I rewrite the integral, I just get the integral of sine squared of u times 1/5 du. And if you want, you can bring the 1/5 out and write it as 1/5 times the integral of sine squared u du. Who's with me so far on that? Okay, now, at this point, you would have to go through all of this procedure in the previous example if you didn't know what you know now. But you know what the end result is. In respect to x, it's x divided by 2 minus sine of 2x all over 4 plus c. But our integral is in terms of u, right? So you change your x's to u's and you write the results. Okay? So we're going to do that. We're going to save time. It's going to be 1/5, okay, times the quantity now, u divided by 2 minus sine of 2u, all divided by what? 4 plus c. This is using prior result. Let me write that down. Using prior result. Doesn't that save time? I mean, a lot of time, right? So it helps to memorize some prior integrals. And you're going to be required to do that throughout your calculus and math career. So just get used to that. And then you have to bring in, well, you know that u is 5x. So I better bring back the x's in. And so I get 1/5, okay, times, what is that? 5x divided by 2 minus sine of 5x divided by 4 plus c. And what do you think the last step is going to be? Distribute through. Okay? So here we go. 1/5 of 5x over 2 just becomes x divided by 2. The 5's cancel. Okay? And then minus sine of 5x divided by what? What? Where's my mistake here? Sine of, 2 times. 2 times 5x, 10x here. I see it. Okay, so 10x here, yeah, that should be a 10. Okay, all divided by a 5th times a 4th is a 20th. What's a 5th times c? Just c. Constant times a constant is a constant. Okay? All right. Yeah, but you have to, well, no, it's not harder, but it uses the same techniques. Okay? So, this time I'm going to, well, you need to, I'll tell you what, I'll start it off. We need to recall something again from last semester, so I'll start you off here. So, here we go. We need to make another substitution, because right now we don't know of a function whose derivative is cosine squared x. So we have to figure that out. So we do know that the cosine of 2x is equal to 3 different things. Okay, but instead of last time we picked the version that involved sine squared x, we want the version now that involves cosine squared of 2x. Cosine squared of x. So what is that? All together, 1, 2, 3, go. That'll work. Okay, so 2 cosine squared x minus 1, and you have to isolate your cosine squared function. So you just have to add 1 first. This one's actually easier. And then you get that is equal to 2 cosine squared x. And divide both sides by 2, and you're done. Right there. And so that one's a little bit quicker, a little bit easier because you don't have to deal with a negative sign or a difference. So from here you want to take this and you want to make a substitution. And you rewrite the integral as the integral of cosine of 2x plus 1 all divided by 2 dx. And integrate from here. Okay, I'm going to pause the video. I want you guys to do this on your own. All right, let's check it out. So we've got the integral of 1/2 dx plus the integral of cosine of 2x divided by 2 dx. Who's noticing that it looks very familiar? Very similar to the previous one. All right, and then this one gives you 1/2 dx and plus 1/2 the integral of cosine of 2x dx. You guys do u substitution there?
Yep.
So if u equals 2x, u equals 2x, du is equal to 2 dx. So 1/2 du is equal to dx. So this is the same thing as 1/2 times 1/2 times the cosine of u du. Who's with me on that? Yeah? Okay. What's the integral of cosine? What is it? I heard a negative sign, I heard sine. Which one is it? I still heard two different answers. It's positive sign because derivative sign is just cosine, yes? So here we go. So we get 1/2 x plus 1/4 sine of u, but u is 2x, plus c. So let's rewrite this like the other way. What's the only difference between this result and the previous one for the integral of sine squared dx? The minus and the plus. The other one's a minus, this one's a plus. So you're lucky that the forms look identical. The only thing, well, not identical, very similar, and the only thing that changes is a plus to a minus. Okay? So we have to commit that to memory. And then you can handle number 10 real easily. Okay? Holy cow, man, I've got more examples. Okay, so I'll have to continue this on the video on my own and then have you guys finish up later. But you know, here's the deal.